All right. Hey, everyone. My name is Kaustubh Phatak. We are in the blue stage, so you might want to put the blue lights on for your headset. And then if you're unable to hear for any reason, just raise your hand. Someone will come and help you. With that in mind, my name is Kaustubh Phatak. I'm the product manager on the AWS WAF team. And we are here to talk about AWS Threat Intelligence and how that threat intelligence becomes managed firewall rules that customers can use with multiple offerings. With that said, Paul, do you want to introduce yourself?
Yeah, sure. Hey, guys. I'm on the AWS Shield side. I run a threat research team that looks into all of the threats that we see hitting the perimeter of AWS. And so we're going to talk a bit about that. I'm excited to be here, and thank you so much for joining our session.
Awesome. So just running down some of the agenda for this presentation. So we'll start off with perimeter protection. That's the team we are in. So we'll just give you a background on what we do, who we are, why you should care about listening to this. We'll also cover a little bit about the different sources of threat intelligence that we as AWS collect, and then how we use that information to turn into actionable insights that are available through managed rules with our different services. We'll also take a look at targeted bot attacks. So these are specific attacks coming from bots, and how we take additional threat intelligence in mind to protect against those attacks. And then we'll just round off with an attack scenario where we saw a customer getting attacked, and we were able to use the threat intelligence and other stuff to help this customer. And then we'll just conclude and end. So who we are and why do you care, right? So we are perimeter protection. Both me and Paul are from the perimeter protection team within AWS. Perimeter protection team consists of 4 AWS services: AWS Shield, AWS WAF, Network Firewall, and Firewall Manager. AWS Shield is our DDoS mitigation service that helps protect against Layer 3, Layer 4, and Layer 7 attacks. AWS WAF is our web application and API protection service that helps protect against OWASP top 10 and other such attacks. Network Firewall is our firewall for the VPC, and then we have Firewall Manager that does the orchestration of the policies across your several accounts. The goal for perimeter protection team is to protect AWS infrastructure as well as the applications that are hosted on the AWS infrastructure. Paul, do you want to talk about threat research?
Yeah, so our team has a bunch of tools that integrates with these services in perimeter protection. And really what we're trying to do is build mechanisms that are allowing us to extract the threat data about threats that are on the perimeter, and then turning that into actionable threat intel. And we'll do that today. Today I'd love for you to walk away going, wow, you do a lot for us, right? We actually use this intel in our platform to make it a safer place for your workloads. And then we also publish this in some managed rules and features that you benefit from if you're using those today. So that's why we're here, to keep you informed on that stuff, and hopefully you enjoy it.
Awesome. So a lot of customers ask us that how we can leverage the threat intelligence that you as AWS get to better protect our applications in AWS. So really, when it comes to a lot of our offerings, a lot of our managed rules that we have with our products, you're kind of benefiting from the threat intelligence already. Today, what we're going to do is we're going to peel back all the layers of the onion and give you a sneak peek into how we do threat intelligence, how we collect data, how we convert it into actionable insights, and make it available to you as managed rules. So this is important work because we feel internet is a bad place. We don't focus on just protecting the AWS infrastructure. We also go beyond, which we'll cover in the following few slides. So just a high-level level setting of, there are a lot of things that are ongoing with the internet today. We have distributed denial of service attacks. So these are attacks aimed to take down your application by overloading them with multiple requests. We have web exploits such as cross-site scripting, SQL injection, which are aimed towards getting access to your application data. Then we have bots. We have both good and bad bots. So our focus should be to allow the good bots through and then block the bad bots. And then lastly, we have scanners and crawlers. So these are Python scripts or automated software written to scrape your website. So for example, if you have an e-commerce website, these bots would generally look at your pricing on your page as well as the availability of a certain product. So those are some of the categorizations and the types of attacks that we see on the AWS infrastructure. Before we jump into the details, AWS Shared Responsibility model, I'm pretty sure many of you have seen this already. But really what it discovers is the responsibility of the cloud is AWS responsibility, and responsibility in the cloud falls on the customer. So AWS is responsible for protecting all the infrastructure, all the hardware, software, networking, the data centers that run your applications. That is all AWS responsibility. And then the customer responsibility is kind of determined by what product you use, because we have certain offerings that make it easy, that are managed by AWS. So we take some of the responsibility from that area as well, like security in the cloud. But then some of that falls on you as the customer. So this is constantly changing. So like we come up with offerings that help reduce the heavy lifting that you need to do as a customer. So let's, with that in mind, let's just look at some of the threat intelligence that we collect. So before we go to that, so just a glimpse of the services that use our AWS Threat Intelligence today. This is not an exhaustive list. We have AWS WAF, AWS Shield that we already talked about. And then we have Guard Duty, which is our threat detection service, which basically monitors your AWS accounts, looks for any malicious things going on, and alerts you for that. We also protect our AWS infrastructure, which is the data centers that is running your applications. All of this, the threat intelligence, is exposed as managed rules that you can use directly from the console. That in mind, Paul, do you want to cover the threat intelligence piece?
No. All right. So as we embarked on this journey to provide the security of the cloud, we realized that we actually have a unique position, right? We're situated on the front row seat of what noise is going on the internet, and so we've built some tools that help us take advantage of that and do it at the scale and in as fast as possible, near real time, to collect this data and turn it into actionable mitigations for us. So a key part of how we do this is how we listen to what's going on, right? So we run a fleet of threat sensors, and these things are specifically designed to mimic the top applications that are used by customers. They run completely open to the internet, so as they see the same things that your application would see if you left an endpoint completely open to the internet with no protections in front of it. And this way, it gives us a chance to actively listen and see what type of activity or malicious activity is going on. This network, along with some automated malware analysis and active probing and some botnet tracking, really gives us a great insight into understanding what threat actors are doing, and really getting a front row seat view of their techniques, their tactics, and procedures. So in the first 3 months of this year, just to give you an idea of how much we're listening to, our threat sensors received 5.6 billion interactions. Right now, each of those things has a source IP and a whole bunch of data and is trying to do things. So we're going to now dig a bit deeper into what do these interactions look like and what are people trying to do out there. All right, so here's just an example of a really basic HTTP request. And this is what you might see if someone was trying to compromise your system, right? This HTTP request is requesting the the receiving endpoint to go and download a file. That's what the wget command is for. And this file called Sakura is hosted on that IP address. And you download this file, and this is a specific software program that's designed by bad actors to run kind of incognito or behind the scenes on your instance. So you do not want this. You do not want to process this type of request, obviously, in your production environments or anything really on your network. So this is also called a malware file, and the hash for the binary is there. And the next part of the request is giving it all permissions, which makes sense because it wants to run it, and then it executes the file. And now this would be potentially something that's just sitting there, and it could run dormant for a couple of days or months or years, but ultimately it gets used to do malicious things. And so when we receive something like this, we have done this in a controlled manner that allows us to actually benefit from these types of interactions. We want people to do these things to our environment, not to you, so that we can learn the lessons and implement mitigations that help you. You never see this. So what do we get from this? Well, of course, we get a suspicious source IP. We now know we're tracking hundreds of thousands of IPs from those 5 billion interactions that we had in the first 3 months of this year that have done these types of suspicious activities. So we've got the IP that it came from. We've got the signature that it tried to exploit, which is really helpful for WAF or firewall rules. We know that there is now a host out there, another IP address that's hosting this malware. We've got the actual malware itself. Now, this is a critical part, right? It gives us a lot more insight into what this person's trying to do, right? So we download the malware, we run it in a controlled networking environment, and we monitor what it's doing. So usually what malware does, especially in the DDoS space, is it tries to register itself with a C2. A C2 is a command and control server. This server is responsible, it's really the brain of the network, right? And it's the brain of the botnet. So as soon as an instance becomes compromised, it becomes part of this botnet and can be used to do DDoS as well as other types of attacks. And I say a treasure map to the C2 because knowing where the C2 is really important to us. It's gold, right? It's gold for us. And so at this point, we've learned all this from one interaction. Obviously, this is just one. We have millions of these, and we collect all this data, and it's at this point, it's just data. So now I want to pivot a bit into how do we make this actionable? How do we turn this into threat intel that benefits AWS and yourself? So there's a couple areas where we use this internally. The first is on IP reputation, right? I spoke about this IPs we get. I'm sure you guys keep track of a naughty list too. So we do that from across the whole network, and we use that to block enumeration attacks, right? We use these IPs in anomaly detection and algorithms that help us protect against these actors that are performing enumeration attacks on AWS resources. And so we do this automatically today. If you have a workload that's inside of a region, we're blocking traffic already that is from actors that are performing enumeration attacks. Next, we mitigate abuse, right? So sometimes when a instance is compromised and performs abusive activity, we pick this up, and we then immediately act like kind of isolate that instance so it can't perform that abusive activity anymore. And we work with our trust and safety organization to escalate to the customer and help them recover that to a good state. So we've got an automatic mitigation that helps reduce the abusive activity, and then process to work with the customer and get them back to business as usual. Botnet disruption is the interesting one, right? I mentioned that when these instances get compromised, and if they're on AWS, they can be used to launch an outbound DDoS attack. We call it an outbound DDoS attack because the traffic is coming from an AWS instance and it's going somewhere out of the network. Actually, it could also be going internally, right, like east-west. So we want to prevent a botnet from using our capacity to do this type of malicious activity. The way we do that is we take that C2 IP address that we picked up and we put that into a network layer black hole mitigation. So what this does is when C2 send commands and they say, hey, we want you to now attack this target and we want you to do a SYN flood or whatever type of DDoS attack it is, that command does not reach our instances, any instance on the network, right? So now the botnet, the capacity that was running on AWS is no longer able to participate in any of the activities. So the more of these C2 IPs we know about, the more we can disrupt their ability to conduct attacks using AWS infrastructure. That's how we disrupt bots. Just some stats on that. So in the first 3 months of this year, we were able to disrupt 1 million outbound DDoS attacks with this threat intel that we gathered. And then lastly, incident response. This was really helpful for us during some of the 0 days we've encountered. Because we are listening to all this bad noise going on and we're collecting our own indicators of compromise for threats, we're not dependent on external vendors selling us data. You know, we've got this stuff firsthand. We can move as fast as we want. We have our incident response team that kicks in for emergent threats. And so our threat data helps drive and empower that team to isolate and mitigate these threats. And then for you guys, if you're using GuardDuty today, you're benefiting from all this threat data as well, right? We're sharing all the IOCs or indicators of compromise with GuardDuty. GuardDuty is updating their detection signatures with these IOCs as well as with the malware that we provide. So all that malware that we collect that helps us get to the C2s, we share that with GuardDuty, and they're able to update their signatures so you can automatically benefit from what we're gathering. That's the first source of threat intel that we get. The second one is DDoS attacks. Now I want to talk about inbound DDoS attacks, right? So this is traffic coming from outside of the AWS network, targeting something on our network. And this happens a lot. It's an old vector, but it's still really popular. We mitigated last year 700,000 DDoS attacks. Interestingly, 48% of those were application layer. So that's where I want to focus our conversation now. Application layer, also known as layer 7, are HTTP request floods, so really large volumes of web requests that just overwhelm your server. And we've seen year over year, 40% growth in the number of attacks that are leveraging the application layer versus the infrastructure layer. Last year, we mitigated an attack that was more than 5 million requests per second. And a lot of these high volume attacks are trying to use proxies. That's been the interesting thing for us right now, because just like on network layer and infrastructure attacks like a SYN flood or a reflection, a DDoS attack, you spoof your source so you can obfuscate the origin of the traffic. For layer 7, we're seeing a lot more use of proxies. Now, let's talk about how they're doing this. So this is the kind of architecture of what a DDoS for sale service might have, right, for layer 7 attacks. You've got the target, obviously, and then the target gets hit with a lot of traffic coming from 1,000 or 10,000 different IPs, and on each of those IPs is a proxy server. Could be a Squid or SOCKS, those are pretty common. And the reason why they use the proxy is because it just forwards on the request and it changes the source IP, then becomes the proxy IP. And sometimes these proxies are used for legitimate traffic too, so it makes it difficult. You can't just, like block that IP, right? Because you might be blocking legitimate IP from the legitimate traffic as well. But behind the proxies is a proxy driver. So they have a fleet of proxy drivers. In our experience, it's around 5 to 10 beefy instances or compute capacity hosted anywhere on the internet. And this handful of drivers sends requests to the thousands of proxies that then get funneled onto the target. And from our intel, we've seen a lot of, obviously, there's lists of open proxies that you can find on the internet today that get abused for obvious reasons. But interestingly, they're also using private proxies. And a private proxy network typically has more dedicated bandwidth. It allows you to do higher volume tests, DDoS attacks, so to say. And I don't know how they get in. They probably brute force their way in because it requires some level of authentication. Or it's part of a DDoS for sale service. But the use of private proxies has been increasing over the last 12 months. So just to give you an idea of what we see, when we look across all of the L7 DDoS attacks that happen on AWS, we keep track of some bad IP addresses that are frequently hitting us. And here is a list. I grabbed this from one of our dashboards. There's around more than 26,000 proxies that we know about on the internet that are contributing to 88% of the DDoS attacks. Right? So we keep track of these IPs, and we use these IPs to, when we respond to a DDoS attack internally that might be causing pain somewhere, we use this because this list is immediately effective. We know about this from previous attacks, and it's common for this infrastructure to be reused. We also make this list available to you. So this list is available in AWS WAF today. There is a reputation rule group that is called the Amazon IP Reputationist. And there are a couple rules there. The one that says the IP DDoS list is that list of IPs that we have curated from across all the L7 DDoS attacks. So you can use this today. This rule is in count mode, which means that the default action is just to count. The reason we've done that is because it includes proxies. So if you ran this thing always on in block mode, you're probably going to run into some false positives. You're going to catch some dolphins in your net, and you don't want to do that. So it's important. Like, I think ideally what you'd want to do is, as part of your incident response process, maybe your runbook has this as a step to add this rule in or switch it to block mode or something. You could also have a rate-based rule. WAF recently launched a feature where you can rate limit on a label, and this WAF rule emits a label, and you can create a rate-based rule that rate limits traffic matching this list. Of course, the most ideal is that this list is just placed for you automatically. And that's what we do today with Shield Advanced. So Shield Advanced tracks the baseline for your resource, and then it does some anomaly detection. And the moment it detects a DDoS attack, it immediately places that list. Right? So that list of 26,000 IPs is immediately in your WebACL in block mode in under 10 seconds. And that has proven to be really effective for our customers. And then while that's blocking traffic, we're analyzing the traffic to place a signature-based rule in case it comes back with a different set of sources or something. So that's Shield Advanced Application Layer Mitigation. All right, now the really interesting part that I love talking about is how do we take this threat intel and make a difference to the wider security community. You know, a lot of the intel we gather is critical to us, obviously. It's critical to you, as we've been talking about, but it's also critical to our partners out in the security community. And so we try to get involved in what we call takedowns. A takedown is really us reporting abuse on another network to say, hey, we noticed something on your network is causing abuse on the internet. And so what this entails is, let's take the example of the proxy-based attacks, right? So we would observe a proxy driver that has been initiating attacks, and we will report that to a hosting provider or a network that owned that. If we see a domain that's being used for C2s, then we will report that to the domain registrar, and we provide all the data, and then they will take down the domain. And essentially what we're doing here is we're not getting rid of DDoS, we're not going to get rid of all of that from the internet today. But what we are doing is we're driving up the cost. And so for my team, what we're trying to do is make AWS the most expensive place to target. That's our little mission, right? We want to make it the most expensive place to target, because if you hit us, we will be able to trace back your attack to the original infrastructure that you used, and we will work with our partners in the community and take down your infrastructure. And then you have to go and rebuild, and they do rebuild. And depending on what we do, it can take them a while to spend that time and effort to rebuild their infrastructure, which costs them engineering time. It costs bad actors revenue, because now they've sold the service and their customers are unable to use it. So this is a really exciting part that we're getting involved in. So far in 2023, we've shared our intelligence on nearly 1,000 botnet control and C2 hosts, and we've helped disrupt like around 230,000 DDoS attacks that have been coming from proxy drivers. So it's been pretty interesting so far, this sort of work. So I want to deep dive a bit further into this and talk about some case studies. All right. So here is a domain that was used, freebot.c2. It's not the actual domain. I didn't want to put it up because I know someone here is probably going to browse it. So I put a fake one up. This domain had 5 to 10, I think, different types of IPs behind it, and it just redirects malware to an IP address where the C2s are hosted. So there's some bad actors have built in some resiliency in their infrastructure. This was a malware type, like a Mirai derivative. And by using our techniques to kind of isolate and to isolate these devices and let it run, we were able to identify the C2 and track it and eventually get it taken down. So this is what we saw. So by running the malware, what that does is it allows us to track commands for the botnet, right? Because this malware is running in some little contained area, it gets a command which is normally encrypted, so you've got to decrypt that, and then you can see, hey, this is the target, this is the type of vector. Sometimes it has a duration, some other interesting things. And so here is the data from the 14th of May, starting on the 14th of May up to the 17th of May. And we peaked at like more than 35 DDoS attack commands initiated from the C2, which is quite a lot. I mean, that's a lot of attacks over a shorter period of time. Here are the networks that the C2 was attacking. So Amazon is there. The moment we get the C2, as I said earlier, we go and put that network layer black hole in, so we've disrupted it from using AWS capacity. So we've disrupted it, but it's still initiating attacks, right? Because it's got botnet capacity outside of AWS. It's initiating attacks against a number of different networks, as you can see here. So it's quite widespread. So what we do is we collect all this data and we share it with the host. So here's an example of an email we sent. You can see the command that's coming from the C2, and we put all the IP addresses in there, and we give all the examples and data to say, please, can you work with us? Take this thing down. I mean, this thing is causing pain. We don't want it anymore. And we get these types of responses. So Njala is the domain registrar. They responded to say, thanks, we've taken this down. The hosts, the C2s that the domain was pointing to were hosted on DigitalOcean. They responded to say, we've wiped these accounts out. And actually, DigitalOcean, I just want to call them out, have been a really strong ally and partner for us. the work we're doing here is best effort, right? We're submitting an abuse report, and they're not all actioned with the same amount of urgency. And DigitalOcean has been really helpful in that regard. They've been super responsive. So here is a wider look at all of the C2s that we're tracking. So we got, that was just one example that we were talking about now, but this is a breakdown of all the networks that we see being targeted by the C2s that we're tracking. Right, so there's a lot of work for us to do here. There's a lot of work for us to collect this data, submit it to the networks, and hopefully influence them in a way that they respond positively to our reports. But by doing this, we're able to clean up C2 infrastructure that's causing bad things to happen all over the network and all over the internet. And as you saw in that graph earlier, it's not just Amazon that's being targeted. All right. Next, let's talk about a proxy fleet. This is actually a proxy driver fleet. So these are those drivers that are sitting behind the proxies initiating the L7 attacks. So similar story here. We saw this proxy driver fleet that was hosted on DigitalOcean. So we were able to trace back from our L7 attacks hitting AWS to these drivers that were running, that were behind the attacks. So here, this was back in April. We were seeing, close to 400 L7, or on one day, more than 400 L7 DDoS attacks initiated by this one fleet. And you can see how it drops off because that is the work of our takedown requests that we sent to DigitalOcean. In the case of proxies, we collect. We don't want to report abuse and be wrong, right? So today, when we do this, we make sure that we collect enough data and have evidence of the type of HTTP traffic that's being sent, and give everything that is needed for this hosting provider to respond and action the takedown. Here are the attacks by network. So a lot of attacks going on. Amazon's third on the list there. You can see kind of the long tail of networks that get targeted across from this driver fleet. All right, and so on the left is an email we sent saying we found some drivers that are hiding behind open proxies. Here are the offending IP addresses. Here's some timestamps and targets that they were hitting. And then great response back from DigitalOcean saying we've terminated one user. I'm not too sure what that means, but they terminated something and it made a difference. So it was great. Like, again, really helpful that these guys are working well with us and partnering to take and clean up things on the internet. So this threat intel is making a big difference. Here is an example of, this is not an example, this is again taking a step back and going, hey, let's look at all of the proxy drivers that we're tracking. And this is, these are the networks that are hosting those proxy drivers, right? So if you work for one of these companies, I'd love to talk to you. We want to give you more threat intel to help, so you can help us partner with you to action these things and do, for the wider security community, clean up some of the mess that we're seeing on the internet. Great. I'm going to hand over now to Costa.
Thanks.
How's it?
All right. So we understand that AWS-wide coverage or threat intelligence can only get us so far. So there are certain types of attacks that require custom threat intelligence, right? So these attacks are targeted to specific applications, specific workloads that you are hosting in the cloud, and that's where the threat intelligence also has to be customized. So that's where we can talk about bot intelligence. So our the way that we protect against bot attacks that are targeting your application is that we customize your protections based on the individual applications. So before we go into like the details, let's just level set on what a good bot and a bad bot is. Not all bots are bad. We want certain bots, such as search engine crawling bots or vulnerability scanning bots, to be there on your website and crawl your website. However, there are certain traits that we usually see with good bots. First, they identify themselves, they use APIs, they rate limit, they look at the robots.txt file, and then look at the rules that you have configured, and then adhere to those rules. Whereas bad bots are an example of that would be distributed denial of service attacks carried out through bot networks. We have content spam, we have different types of frauds like account takeover or credential stuffing that also uses bots to carry out those attacks. So that's the differentiation between like good and bad bots, and we don't want to block all bots, but only the bad ones. So since these bots are targeting your application, our protection mechanism also relies on your application telemetry. So this is one of the use cases how we collect that information. That is the SDK integration. The SDK integration allows us to capture things like browser information, such as screen resolution, or canvas data, or language being used, or geolocations, to collect all of that information from every device that connects to your application. This allows us to do two things. So this action, I'll explain a little bit more in the next slide, but we support all JavaScript for web applications as well as iOS and Android. Integrations are supported for your native applications. Now, diving into a little bit more detail, the second way that you can provide this information to us is through challenge rule action. So this is a proof of work execution where the first request that the client sent to the website does not contain any tokens or cookies. We send a challenge interstitial, so think of this like a redirect. The second flow component that you see, token server, that is one of the components that we maintain on our WAF team. That reaches, these token servers are in every AWS region. So depending on where your customer is coming from, they will be redirected to the closest token server location. They contact the token server, they get sent out a JavaScript challenge. In step 3, they execute the JavaScript challenge. So this is another example of where we want to increase the cost of bot operators that are targeting AWS, right? So there are some dumb bots that you can rent out, which are cheap, but they do not have the ability to execute JavaScript or store the token as cookies. So that's where by introducing this step, we are increasing the cost of the bot attackers so that it disincentivizes them from attacking your website. So let's say the step 3 works fine. They move on to step 4, where they send the challenge solution back to the token server. So the token server does two things. It validates the response for the challenge, as well as it validates the metadata. So if somebody is spoofing this response, and let's say that it's coming from a Windows device which has a Safari as the browser, that's probably inconsistent with what we see. So we look at things like that to determine whether the metadata is inconsistent and verify that the solution that the challenge is responded with is also correct. So if those things are not correct, the request does not go past step 4. Assuming everything is correct, we vend out a token. This token is then sent with every subsequent request coming from that particular client. So now what that allows us to do is it allows us to track this access pattern for this particular token. And then we can create baselines. We can act intelligently on what a particular token is accessing. And then if any anomaly is detected, we can trigger actions on that. So fingerprinting, like we're not taking fingerprints from your mouse when you click into things. Fingerprinting is nothing but a cryptographic hash of all the information that we are collecting. So roughly today for both web applications and the native applications, we collect anywhere from 80 to 100 things. This information then becomes a cryptographic hash, and then that becomes the fingerprint for that particular device. What this allows us to do is track the behavior of that device, even if they use controls like changing their IP addresses by putting a proxy in, right? Or changing the session by opening a new tab in the browser and trying to execute from there. So all of those things do not, like, we are still able to track that devices. The other thing that we offer is like the tamper proofing. So if there is any changes in the user agent being introduced, so we have mechanisms in place where if somebody like an attacker copies the token and then uses bots that are distributed to send multiple requests, we will detect that. There are mechanisms in place where if a token is reused across a few geolocations, then we trigger that and we block those requests. So what this fingerprinting technology allows us to do is to act on a per device basis rather than IP address or any other singular thing like that. So it just increases the difficulty in attackers being able to spoof or tamper with any of the incoming requests. So we don't stop there. Like we have a lot of collaboration within AWS and Amazon. So Paul talked about the IP reputation list, how we collect that. So that information is also used in our bot mitigation solutions. We go beyond that, and we also do email reputation checks. So this is applicable for account takeover prevention or account creation, fraud prevention that we released this morning. So in those situations, we use the reputation of the emails, such as what domain is being used to create that email address, as well as the age of the account. So if it's a new account that's created just to carry out that attack, then that is going to have a high risk score, effectively. Whereas an account which is already existing for 6 months is having a low probability of this being a fraudulent account. The third one is really the stolen credentials database. So this is a list that we cater across multiple AWS and Amazon teams. So the way we collect this information is through looking into the like crawling the dark web to figure out what are the compromised credentials. And then these compromised credentials are updated periodically as and when we see any new information. What that means for you as the customer is you get an option to whether say yes or no to compromised credentials. So you can still say, hey, I know that this is a compromised credential that is trying to access my application. You may not want to outright block it. You may want to capture it, or you may want to do something else with it. Maybe you have a honeypot running somewhere and you're redirecting this request to get more information about their attack vectors. So all of those things are available, or you can outright block or disallow stolen credential usage on any of your applications. The fingerprinting that we talked about briefly allows us to look at both good and bad fingerprints, or fingerprints that behave good and bad. So what we have done with that is the bots that we know are good over a certain period of time, we add them to a list of verified bots or verified good bots. So this list is available to customers through our managed rules. And then you can say that, okay, I know this is a good bot and this is a search engine optimization bot, so I want to allow those type of bots into my application. So you can just say yes or no, and then they can access or not access your application. Lastly, again, we work with the threat research team on the malware detonation piece. For the malware detonation piece, the information that the threat research team collects, we use that as label data to run our bots and fraud detection models. So the more data we see through the malware detonation team, it makes our detections and mitigations better. So even though we need to customize our solution to the nature of attacks and the threat, the idea here is that you still benefit from the Amazon ecosystem of threat intelligence. So let's jump to a real world attack scenario where we helped a customer protect against spikes in traffic. So this gives you an example, like this is a screenshot from our dashboard where we were seeing this customer hit with 1.4 billion requests at peak on day 2. There were some attacks on day 1 And then once the attack peaked on day 2, that's where we worked with the customer to protect against this type of attack. So the first thing that this customer did was use basic mitigation. So we worked with the customer to tell them that, hey, there are certain countries that we are seeing traffic from where you do not operate, right? So then if you do not operate, then you may not want to receive traffic from those countries. So they used basic geo-blocking rules. Rate limiting rules, what Paul talked about, were also used to block a lot of requests coming from, say, one IP address or one X forwarded for IP addresses. We used the hosting providers list to block any hosting provider IPs that were accessing the application. After applying these basic mitigations, we looked at the WAF dashboard to look at the amount of bots that this customer was getting. Now, the screenshot I've included here is just an example, so it's not the actual customer screenshot. But this is how the customer figured out that there is a lot of bot traffic coming on their application. And that's where we decided to implement targeted bot control. We also helped the customer do additional log diving and forensics to figure out that the spike that you see that is highlighted in yellow over there is there were 10,000 different IPs sourced all across the world. We also were able to see which is highlighted in the green dotted line on the graph, that a lot of these requests did not have any tokens present. So tokens, if you remember from the challenge action or the SDK integration slide, these are the proof of work that a bot or a user has to do to prove that they are not a bot. So we saw that they were not doing that. So that's the first rule that we used. We used challenge action to challenge these incoming requests, which resulted, and it worked great. Like challenge action, we were able to show challenge action to 97% of the total spike traffic that you see. So the green line that you see there was the challenge action being served. The orange one was the total requests. And then over there is this blue line, which talks about the number of challenges that were solved. So the actual number of challenges that were solved and the requests were allowed through. So as you can see, like just by using challenge action, the customer was able to reduce a lot of traffic coming to their application. Second action that we implemented was the CAPTCHA action. CAPTCHA did not see a lot of traffic. There was maybe about 3%, 2.7 to 3% of total traffic was shown CAPTCHA. But if you see in the graph there, when the spike happened in the red, a lot of CAPTCHAs were issued. And then the CAPTCHA solve rate, the green line that you see next to the spike, that was the percentage of the CAPTCHAs that were actually resolved. So using CAPTCHA action, even though the total request was less, we were able to block a majority of the traffic that CAPTCHA saw. Later on, you can also see that the CAPTCHA solve rate increased. So this was not during the time of attack. So this probably is the legitimate users that were solving the CAPTCHA to access the application. Next, since the attack that we saw was coming on the login endpoints, we decided to apply account takeover prevention rule set. So this is a managed rule that helps protect your login pages against credential stuffing and other brute force attacks on your login page. So some of the examples there, you can see like there are token rejected. So that's a bot mitigation control that we have added with our fraud offerings as well. There were some other things such as volumetric IP, volumetric sessions that allowed customers to block those requests coming from one session or one IP. But in this case, we saw most of the attack was coming from compromised credentials. So when the customer saw this, they moved the action from count to block for the compromised credentials. And then we were able to see that a tremendous reduction in traffic on day 3. So the attack was cyclical. We did not see any that attack spike up on day 3. Like overall, AWS Threat Intelligence that we collected through various sources, the WAF rules, the basic rules, the bot control, and account takeover prevention, we were able to use a layered approach to help this customer protect against this spike in traffic that they saw. This is just a table that talks a little bit about the summary when it comes to metrics. So we saw that rate limiting worked great. We saw 14 million requests were rate limited and were blocked. Now certain actions, so for targeted bots, we have volumetric IP token absent. So that's a rule that gets triggered when one IP sends a lot of requests that do not have a token. Volumetric session is exactly the same thing for sessions. So we track sessions across devices, and then if we see a lot of sessions being created from a particular token, then we trigger that rule. So that rule was able to detect like 14 million requests with 100% of the requests were being captured. We also saw some non-browser user agent. So this is headless Chrome. This is your Selenium, Puppeteer Stealth, any of those softwares that were used, Phantom.js, as well. Like Phantom.js is pretty old, but yeah. So like those kind of softwares were also being used to carry out attacks. So 4.5 million of those requests were we were blocking those requests coming from those sources. And we have lastly the two browser inconsistencies, the difference in the metadata of the request when the challenge is solved that we talked about. So that's like 1.6 million requests, and all of them were capture. Then lastly, we also have another list that we maintain for known bot data centers. So this is a list of IPs that we maintain that bot attackers have previously used in different attacks and are coming from a data center. So if you have an application where you do not expect your traffic to come from a data center, then that is a good rule to apply as well. So we saw a good block rate on that too. With that in mind, I think I'll come to the conclusion. So really what we wanted to tell you in this talk is we're doing a lot of things behind the scenes to make AWS Threat Intelligence up to date and available to you. And then we make it available and easy to use through our managed rule offerings for various services. We saw AWS WAF, Shield, Guard Duty. We do the same thing with network firewall and other some services. Then the whole idea or the key message that we want to give through this talk is that we are doing this heavy lifting to make it easy for you to consume, and so you don't have to do those threat intel yourself. So we want to make it easy for you to use that to protect your applications.
Yeah, and one thing I'd add is, if I didn't articulate it clearly earlier, if you're wanting to work with us on that work that we're doing beyond our border, right, those takedown requests that we're initiating, I don't know how many other people are doing that, but it's definitely something that the security community needs to get involved in together. And so I'd welcome a conversation with you on how we could partner that way.
Awesome.
Thank you so much for joining us today. It's been great to have you here. Just a reminder, if you can take off your headphones and put it on your chair seat, that would be helpful, not on the backrest. Thank you so much.
Thank you.